Hi and welcome to my YouTube channel. So in the previous video we have discussed about the embedded system design model, how to build an embedded system and what are the significant components in an embedded system. So today we will be starting with a new chapter, that is 8085 Microprocessor Basics. We will be looking at the following contents, that is features of 8085 and 8085 architectural model. We will start with the features of 8085. 8085 is developed by Intel. It is an 8-bit microprocessor, that is it can accept 8-bit data simultaneously. Then it can be operated with a single plus 5 volt DC supply. It works on 3 MHz clock frequency. It has 8-bit multiplexed address and data bus. It has 16 address lines, which means that it can address up to 2 power 16, that is 64 kilobyte of memory. And it has 5 hardware interrupts, namely trap, RST 6.5, RST 5.5, RST 4.5 and INTR. So these are some of the notable and significant features of 8085. This is the architectural diagram of 8085. In this diagram there are many components, but we can say that 8085 architecture can be divided into 5 major blocks. First one is the register array. Second is the arithmetic and logic unit or the ALU. Third is the instruction decoder, timing and control circuitry. Fourth is the interrupt control circuitry. And fifth one is the serial input output control circuitry. So let us look at each block in detail. First one is the register array. In register array itself there are various components. The first one is the general purpose registers. There are basically 6 general purpose registers in 8085. They are B, C, D, E, H and L. Each register holds 8-bit of data. They can also be combined to form 16-bit register pairs, that is BC, DE and HL. They are used in storing the intermediate data and result. Hence they are called general purpose, that is they are not used in any special purposes. They serve general purposes alone. Next is the accumulator. Accumulator is nothing but an 8-bit register that can hold the result of arithmetic, logical, input output and load store operation. It is connected to the data bus as well as the ALU, because whatever the operation that is happening in the ALU, the result will automatically be stored in accumulator. The next component is the instruction register and decoder. It is an 8-bit register, and when an instruction is being fetched from the memory, it is getting directly stored in the instruction register. The purpose of the decoder is to decode the information that is available in the instruction register. The last component is the flag register. It is also an 8-bit register having 5 flags, and these flag bits can take values 1 or 0 depending on the result of the operation that is stored in the accumulator. That is, the flag registers, it will reflect the status of the result stored in the accumulator. The next important unit is the ALU or the arithmetic and logical unit. It is one of the most integral parts in the architecture. It is used in performing arithmetic and logical operation, and whatever the operation that is performed in the ALU, the result will automatically stored in the accumulator. ALU can accept input from different registers that are available in the register array, but the result will definitely be stored in the accumulator. Next is the instruction decoder, timing and control circuitry. So the purpose of the instruction decoder is it decodes the opcode that is stored in the instruction register. This will be encoded and given to the timing and control circuitry. The control circuitry is called the brain of the CPU, and it will generate the timing and control signals for communication between the processor and the peripherals. Hence this unit is one of the integral parts in the block. Why? Because this block has the control circuitry which forms the heart and brain of the CPU. The entire procedure is handled using the control circuitry. Next is the interrupt control. So what is an interrupt? Interrupt is nothing but the occurrence of some external disturbances. So once you are servicing the interrupt, the microprocessor will start its normal operation. There are 5 basic interrupts available in 8085. They are trap, RST 7.5, RST 6.5, RST 5.5 and INTR. Last block is the serial input-output control block. This block is mainly used for serial data transfer, where the data will be transferred on the data lines, that is D0 to D7 lines. Serial data will be entered through the serial input data port or the SID, and the data will be given out through the SOD port or the serial output data port. So this is the architectural block diagram of 8085. So I hope that this video was informative. For more videos and updates, please stay tuned to my channel Anju's Learn Point. Thank you.